Hello, in this video we are trying to determine the volume of this cylinder which is under the plane of this paper plate and the book. So let us say the paper plate has the equation C is equal to 3 minus x minus y. So C is equal to 3 minus x minus y. That's the paper plate equation, and below say the book has the equation C is equal to 0, like it's on the xy plane. Okay, now we are trying to find the volume of the cylinder which is under these two planes. Remember, for the cylinder we can use the cylindrical coordinates. So let us use cylindrical coordinates r, theta, z. So before we go further, we need to determine the limits of integration. So let us set up the triple integral, and let us determine the limits of integration. Remember, to determine the limits of integration for one variable, we need to freeze the other one. So let us say we want to determine the limits of integration for z. So we need to freeze r and theta. So at a particular theta, from the last video we saw, it's actually a plane. Yeah. So it's actually a plane like this, a particular theta. And we also need to freeze r. So at a particular r is going to be a line anywhere in this plane, any line in this plane. Okay, now we froze theta and r. We need to determine the limits of integration for z. So we have seen z is varying from z is equal to 0 to 3 minus x minus y. So a particular line in this plane is going to vary from 0 to 3 minus x minus y. So those should be the limits of integration for z. Okay, now we determine the limits of integration for z. There is one more thing here. We cannot write x minus y here because in polar coordinates x is r cos theta. I'm sorry, cylindrical coordinates x is r cos theta, y is r sin theta. So we should rewrite this as 3 minus r cos theta minus r sin theta. Everything should be either in cylindrical coordinates or rectangular coordinates. Here we try to use cylindrical coordinates, so we should rewrite this x and y, which are rectangular coordinates, into cylindrical coordinates. Okay, now we determine the limits of integration for z. Let us determine the limits of integration for r. So how many lines can we draw? How far can those lines go? R, if this base of the cylinder in the xy plane is a circle of equation x square plus y square is equal to 1, can also be written in cylindrical coordinates as r is equal to 1. So r is 0 is this line, and it goes on. R is equal to 1 is this line at the boundary. R is equal to 0 is this line here. R is equal to 1 is this line here. So these lines can only vary from r is equal to 0 to r is equal to 1. If it goes beyond r is equal to 1, that's going to go outside the cylinder. So 0 to 1. And finally, we need to determine the limits of integration for theta. So this is just one plane. This is at a constant theta. But we need this plane, 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 all these planes. Then only we'll cover the entire volume. So theta should vary from theta is equal to 0 till theta is equal to 2 pi. And the area element in cylindrical coordinates is r, dr, d theta, dz. Okay, these are the limits of integration for z. So let us integrate with respect to z. Z 0, 3 minus r cos theta minus r sin theta. Okay, now you can either do r dr and do these limits of integration, or theta and apply these limits of integration, because the top part of this one is not dependent upon this one. It's just 0 to 1. So the one is not dependent upon theta. Unlike for z, we need to do z first because that has both r and theta. But r and theta are not dependent on each other. So we can either do the limits of integration, the integral value with respect to r or theta. Let's do r. So we have r dr here on the outside. So this becomes 3r minus r square cos theta minus r square sin theta dr. 3r square over 2 minus r cube over 3 cos theta minus r cube over 3 sin theta. Now we can apply the limits of integration 0 to 1. 3 over 2 minus 1 over 3 cos theta minus 1 over 3 sin theta. Now we can apply the limits of integration with respect to theta. So if you integrate this with respect to theta, maybe I'm assuming the integral sign. Okay. 3 over 2 theta minus 1 over 3. The integral of cos theta is sin theta, and the integral of negative sin theta is positive cos theta. Okay. The limits of integration for theta are 0 to 2 pi. So 3 over 2, if you apply the 2 pi here, that becomes 2 pi minus 1/3. Sine of 2 pi is 0, so I don't even have to write that. Cos of 2 pi is 1 plus 1/3. And then if you apply the lower limit, 3 over 2 at 0, theta is 0, so we don't have to apply this. And at sine value at 0 is 0, so we don't also have to evaluate this. Lastly, cos at 0 is 1, and because that's the lower limit, we need to write negative 1/3. So these two cancel, and finally we get 3 pi. That should be the volume of that cylinder between those two planes. Thank you for watching. Bye.